So we want to do 4, 10, 18, 19, 20. Is that about what I understood? Is that right? Are we 19 and 20? 20, so, oh, there's 5 parts there. Okay, we're in. Let's do it. All right, I have to escape out of the Zoom mode. And let's have some fun. All right. So problem number 4. So quick question. Who in here has taken pre-calculus? What is this by definition? Stirrups mortuary, you stab them, we slap them. Why'd they hang up on me?
Couldn't imagine why.
You guys remember what this is from pre-calc?
Isn't that game? Trying to think of games.
Definition of a derivative. This is the long version of derivative. All right, so being that it's the g, that means we're going to use the g equation. This is my g equation that they tell us. Okay, so we're going to use this equation. And what we're going to do with this equation is I'm going to plug this in for my x to fulfill that. So I'm going to get 4x plus h plus 7. So that takes care of that, right? Minus g at x. Well, this is g at x, just 4x plus 7. I'm going to put that in parentheses because we're subtracting that quantity. And then we're going to divide by h. There's no h up there, so we just divide by h. Is that okay so far? Okay, let's see what this is. I have to distribute over here, so 4x plus 4h plus 7. Distribute there here, so I'm going to get minus 4x minus 7 divided by h. Okay. Hi! What you got? Birthday cards?
Sure.
Yay! All right. This is for you, my friend.
You can take that.
Thank you.
Thank you.
Oh, yeah, she really could take this one back.
So I had an algebra class. I remember algebra 1. I used to be down the hall on this side, and it was one of those where the kid comes to escort a student to the dean. Here I have to escort this kid. It's like, Johnny, so-and-so, they're going to escort you to the dean. The kid grabs his bag and he runs out the door. I looked at the kid. I said, "Go chase him." I thought it was funny.
I'll go back to the dean's office. Like,
Whatever happened.
I'll get paid to do this. Like, I'll chase them.
So, when we start working this problem, my friends, first thing I'm going to do is I'm going to look for like terms. So those are like terms. They cancel. These are like terms. They cancel. So I wind up getting 4h over h. H's cancel, so my answer result is 4. So the first derivative, and you want to talk about dimensions, a derivative is one dimension lower than the original equation. So, kind of cool. That's number 4. Oh, a little different. A little different. All right, then we had number 10. Number 10. Ooh, find the exact values of x. We want to know what happens here. Okay. So g at x, they give us this up above. Okay. So basically what I want to do is I'm going to put this 0 in. So I get 0 equals x squared plus 5x minus 7. Okay, I will tell you that won't factor. Agree? So we have all these different methods, including my least favorite thing ever. I don't like the quadratic formula. So you know what? We're going to take the quadratic formula off the table because I don't like it. So now we're going to solve this by doing something called completing the square. Completing the square is a much better, more accepted, less signs way of doing it. All right, so if I complete the square on this, I'm going to go x squared plus 5x, and I'm going to make it equal to 7. So basically, I move the 7 over. Agree so far? Now, if you've ever seen completing the square, if you've seen it with me, you know that I make it a little bit simpler. This x comes down. It's no longer squared. This is a quantity squared. This becomes down here. Half of 5 is 5 over 2. Yes? If you square 5 over 2, 5 over 2 times 5 over 2 is 25 over 4. If I add it to one side, I have to add it to the other side. So I know that this is the same thing as 28 over 4, because 7 is the same thing as 28 over 4, plus 25 over 4. So that's going to give me 53? 53 over 4? Okay. So we get that. Then I want to solve for x. So I have a quantity squared. So in order to do a quantity squared, I have to take the square root of both sides. If you take the square root of both sides, don't forget the plus minus. So then I'm going to get x plus 5 over 2 is equal to plus or minus the square root of 53 all over square root of 4, which is 2. I'm going to subtract 5 from both sides, or 5 halves from both sides. So I get this. So my legitimate answer from that is x equals negative 5 plus or minus root 53 all over 2. It's a beautiful exact answer. It's the answer you got with the quadratic formula if you didn't make any sign mistakes. Okay, don't worry. I will always solve quadratics by completing the square. Unless I can factor it. I do not like the quadratic formula. I'm telling you, I keep pushing every year. Why are we teaching the quadratic formula? Oh, because it's a thing. No, it sucks. There's too many signs. I have had students from Algebra 1 all the way through Calculus make a sign error. Because it sucks. I don't like the formula. I don't like it at all. Okay, I'm off my soapbox now. Number 18 was asked to be next. So it's factor the following. Okay. Number 18, factor the following. So I got 6, x to the 4th, 2x. Ooh. This doesn't look friendly to me. This is a little concerning. So a trick that they might have shown you in pre-calc, but they might not have, is this. I have something here that just doesn't look real friendly to me in this problem. So I'm going to do a substitution. I'm going to say that y is equal to 2x plus 3, but I have to keep in my mind that I have to eventually plug that back in. So I'm going to change this problem to this. Does that look okay? And I guess I can get rid of this. I don't need that. Does that look a little bit friendlier? So I just took something that looked like liver and onions, which I don't like. If you like it, good for you. Someone's got to eat it. And I just made it into an Algebra 1 problem. Okay? So what I'm going to do here on this problem is I'm going to say, okay, I can factor 3 out of both of those. Agree? I can factor a maximum of x to the 3rd out of both of those. and I can factor a maximum amount of y squared out of both of those. So if I do that, if I factor 3 out of 6, I'm left with 2. I factor x to the third out of x to the fourth, I'm left with an x. If I factor a y squared out of y squared, it's all factored out. It's just 1. Plus sign stays there. If I factor a 3 out of 15, it leaves me 5. If I factor an x to the third out of x to the third, it's just 1. If I factor a y squared out of y to the third, I'm left with y. Okay, remember in the beginning we did something. We chose to take a portion of it and have it equal to y. Agreed? So I'm going to plug this right here, I'm going to plug it back into my y's. And I think I'm done. I think I'm done. There's no further I have to go. This is the beautiful trick that nobody wants to show you. Yeah.
Where did the 6x come from?
Where did the 6x come
It
from?
was a 3x.
It was a 3. Because I'm making crap up. You know that. Should have been a 3. Is that better?
I think so.
Okay. Yeah, you're right. It's because, I fell down the stairs earlier. A whole bunch of kids pointed and laughed. Hit my head.
So,
19. We say, have you figured out my sense of humor yet?
yeah.
Nobody ever said you're not allowed to laugh in math. You're allowed to always laugh at me.
I didn't laugh a lot in my math classes that I've passed.
Giddy up. You'll pass this one, my friend. So this is number 19. Okay. So I think I'm going to modify this bottom equation to become this. All I did is just subtract x from both sides. And notice I put it as 410 minus x. I know there's a lot of teachers like, no. It needs to be negative x plus 410. No. Let's deal with less signs. Okay, so what I'm going to do, because I know this, I'm going to take this here, I'm going to plug it in right here. So that's going to give me x squared equals 410 minus x minus 300. I'm going to combine like terms on the right side, so 410 minus 300 is 110. I'm going to move everything over. So add x, subtract 110, set it equal to 0. If I go to factor this, it should factor nicely. This is 10 times 11. Should be a positive 11 and a negative 10. And we were solving it because there was an equal sign. Done. Question?
So when you get it from that side, you have x squared and then 110 minus x. Can you just add x and then get x cubed and do the cube root?
It's a great question. Okay.
It's like, don't you still need to solve for y?
Okay. I like what you're saying.
Yeah.
I can't, because let me take you back to like Algebra 1.
Yeah.
You a lot of times could have had a problem like this, right?
Mm-hmm.
Did I add those together?
No.
That's why I can't do that.
Okay.
But that's a great question. And it's perfect question. I love it. Because, yeah, it looks like something like, yeah, I could do this. This question actually came from the SAT 5 years ago. And if you remember your operations of exponents, then you might be able to do it and muddle through it. It comes to a relatively simple factoring problem, but we'll go from there. I like it. I like that problem. All right, and then number 20. Ooh, give it the domain. Given the domain. There's one. Here's another. Here's another. Here's another. And here's another. So these are all the parts. So remember the domain. We're looking to see what might make this problem either an imaginary number or a dividing by 0 number. Okay, so my domain on this one is going to be square bracket 4 to infinity. I can have the square root of 0, yes? So square root of 0 is going to work, so that's why it's a hard bracket on the 4. And I can plug any number, 4, 5, 6, 7, 8, 9, 10, or any decimal or fraction that's bigger than 4 all the way to infinity, and that would work. The domain of this one, you have to remember, I can have, this can be negative. So if that can be negative, the domain of this one is negative to positive infinity. I can plug anything in on that one. Because I can take the third root of negative 8. The third root of negative 8 is negative 2. Because negative 2 times negative 2 times negative 2 is negative 8 in the third root. This one says, hey, the only value that won't work is 8. Because I can't, that would make the bottom 0. So we can't have that. So it's going to be negative infinity to 8. 8 to infinity. The soft brackets on both the 8s means I don't include the 8. I approach it from the left, I approach it from the right. But I can't get there. And then we get to this one. This one becomes a little harder to decipher. So what I'm going to do is I'm going to go x squared minus 16, set it equal to 0. Okay? I could add 16 to both sides. Take the square root. Don't forget the plus minus. Okay. So, if I plug a value between negative 4 and positive 4 in, it's not going to work. A value between negative 4 and positive 4, an easy one would be 0. 0 minus 16 is root negative 16. Root negative 16 is an imaginary number. So the domain of this one goes from negative infinity to negative 4, and it's a square bracket because I can have a square root of 0, and square bracket from positive 4 to infinity. Okay? We're not having anything bigger than negative 4 or less than positive 4 to plug in. If we do that, we get an imaginary term. And then this one. Same kind of idea. If I said x squared minus 9 equal to 0, add 9 to both sides, take the square root, don't forget the plus or minus. There's only two values here that don't work. Everything else does work. Okay, so the domain of this one, it goes negative infinity to negative 3, negative 3 to 3, 3 to infinity. So this one has like a domain on steroids. There's way too much there. There's way too much there.
What did you do with the 2 on that last one?
What did I do with the, I'm sorry?
The 2 on the top.
We ignored it because that's not going to impact our domain at all. Okay, guys, it's just a constant. We feel good about the homework? Did y'all get it done?
Yeah.
I hope so. Because I'm going to put the points in for you. All right, my friends. I have a little quiz. Now, during this quiz, you might have a question. So by keeping yourself socially distanced from your neighbor, if you need to ask your neighbor, dude, how'd you do that? Okay? Now, if your neighbor don't know, ask another neighbor. Agree? Sounds good? Now, I'm going to warn you on this. No photo math, please. No photo math. I'm not testing to see if photo math knows how to do it. But you can ask each other. Socially distanced. My friends, I know I wrote this quiz, and I know on the directions above says one problem will not factor, so write prime. Well, I clearly can't do math. 2 of them are prime. 2 of them are prime. You are allowed to talk amongst each other, socially distanced, to get this done. And I don't have homework for you all over the weekend. I hope nobody cries themselves asleep because of that.